Now here we're going to look at what we call rational inequalities, and they're rational because we have a rational function or a rational expression here, and so we're going to use a similar system what we used in the polynomial inequalities, because the idea is we want to find the roots, whatever makes the numerator 0 and whatever makes the denominator 0. However, let's look at this problem first. We have x plus 1 over x plus 3 is greater than or equal to 2. So we want to know where is that happening. But because we have a 2 on this side and not a 0, we actually have to have a 0 on one side to find the roots. So we're going to subtract 2 from both sides to begin with, and then simplify the rational expression. So we have x plus 1 over x plus 3 minus 2 is greater than or equal to 0. I subtracted 2 from both sides. Now, I want to combine these two. So remember, I have to find a common denominator, the least common denominator, which is x plus 3. And so I multiply 2 by x plus 3 over x plus 3 to give me a common denominator, and now I can combine these two to have x plus 1 minus 2 times x plus 3 is greater than or equal to 0. And then we simplify this further. I have to multiply negative 2 through the parentheses to get x plus 1 minus 2x minus 6 over x plus 3 is greater than or equal to 0, and then we'll have x minus 2x is negative x, and 1 minus 6 is minus 5. So here's my simplified polynomial, rational equation. We have minus x minus 5 over x plus 3 is greater than or equal to 0. We need to find the roots of this inequality, and we see there are two things that make this equal to 0. There are two numbers we're looking at. The denominator, we can see negative 3 makes that equal to 0. So that's one of my roots. If we think of the roots of this inequality, negative 3. That doesn't mean the answer is negative 3, because obviously it can't equal negative 3. That will be an undefined expression here. But that's what divides up the number line. And on top we see if x is negative 5, negative 5 gives me plus 5 minus 5 is 0. So if x is negative 5, that also makes the top 0. So we're going to have to divide up the number line using these two numbers, and then test numbers in between those, in those intervals, in the original inequality to see if it works. So here's our number line with the two roots, negative 5 and negative 3. And we're going to test some numbers in these intervals. I'm going to pick negative 6 here, and between negative 5 and negative 3 is negative 4. And greater than negative 3, an easy number to work with, is 0. So first I'll pick negative 6. If I pick negative 6, and we plug it into the inequality, I get negative 6 plus 1 on top, and on the bottom I get negative 6 plus 3. And I evaluate that, negative 6 plus 1, that's equal to negative 5, and negative 6 plus 3 is negative 3, and that gives me 5/3. We want to know, is that greater than or equal to 2? And 5/3 is actually 1.67, 1.66 repeating. This is not greater than or equal to 2, so we don't want this interval. So let's check the next number, negative 4. If I put negative 4 in here, we get negative 4 plus 1 over negative 4 plus 3. And that's equal to negative 3 over negative 4 plus 3 is negative 1. Two negatives, they cancel to give you a positive. 3. Is that greater than or equal to 2? Yes, that is. So 3 is greater than or equal to 2, so this area we put a yes. And similarly, we check the next number, 0. If we plug in 0 here, we get 0 plus 1, 0 plus 1 over 0 plus 3. That gives you 1/3. Is that greater than or equal to 2? No. That's not greater than or equal to 2. So this area is no. So we've checked all three, and so actually the only solution we have, the solutions occur between negative 5 and negative 3. So how do we write that? This is what we want, between negative 5 and negative 3. How do we write that? Well, since this is an inequality and not strict inequality, we can use brackets. We can use brackets from negative 5 to negative 3. Brackets. Hold on, there's a problem here. Negative 3 makes the denominator 0, so the solution can't include negative 3. So we can't have a bracket here. We have to have a parentheses, even though it's an inequality. So be careful in a rational inequality. You have to see what makes the denominator 0 can't be in your answer. So my solution is between negative 5 and negative 3. And graphically, what does this look like? So this is a rational function on the left, x plus 1 over x plus 3. We can see a vertical asymptote at x equals negative 3. That's what this dotted line is. And a horizontal asymptote, at x equals 1, because they have the same degree. So this would be at x equals 1, horizontal asymptote. So the question is asking you, where is this greater than or equal to 2? Where is this function greater than or equal to 2? So if we draw the line, horizontal line, y equals 2 in this, so 2 is going to be about here, and we draw a horizontal line there. Then we see the function is above this horizontal line, right here, where they intersect. So this intersection here occurs at negative 5, and then it goes on to be above this horizontal line all until negative 3, but it never actually reaches negative 3 because that's the vertical asymptote. So that's why this is the solution here, negative 5 to negative 3, but not including negative 3. And on the other side, the rational function is where it's below the horizontal line y equals 1, so it doesn't even ever go above y equal 2. So that's graphically my solution is from here onwards between these two numbers, and that's how we put it in interval notation.